Hello everyone. Continuing with our discussions on the intermediate code generation and the backpatching. Let us now see how the three address codes can be written for the for loop. The for loop usually is of type where there are three statements in the for loop. First one is the initialization, the next one is the condition check, and the last part is the increment or the decrement part. Now, if we consider that it has a general form like for E1, where E1 is representing the initialization, then E2, where E2 is representing the condition check, and E3, the part of the increment or the decrement. The flowchart of this actually could be like, first the E1 statement executes, and after the execution of the E1 statement, there is a condition check. If this condition is true, then we need to execute the statement S. Having executed the statement S, we need to do the increment or the decrement part, which is E3, and after that we again need to go to check the condition. Okay, so if the condition is true, we will again execute the statement S, and then we will increment with the statement E3, and then again check the condition E2, and if the condition is false, we will come out of this loop. Okay, so the execution is like initialization, condition check, statement, increment, condition check, statement, and again increment, condition check. If the condition is true, statement, then increment. If the condition is, again checking the condition, if the condition is true, we will execute the statement S. If the condition is not true, we will come out of the loop. Okay, now how these three address code can be written for this. At the very first, we should do the initialization. So E1 is the first part that we need to do. Fine. And after the E1, we need to check the condition. So if E2, it means the condition is true, we will go to some level. Let's say that level is not known. But if this condition is not true, certainly we will be going to the last. Fine. So what is the last level? This is not known. We'll write it later. Let's say this level is L1. Okay. Now, if this condition is true, we are going to execute the statement which is S. Let's say this statement is at the L2 level. After executing this statement, we need to do the increment or the decrement part, which is E3. After doing so, we will go to the condition check once again. Fine. So what is the condition check? Condition check is done at L1 statement. So in the backpatching, you can write this L1 here. Fine. Now if the condition is true, you're going to L2 to execute the statement S, and followed by the E3. If the condition is not true, in that case you will come to the last. Let's say this is the last level. Right? So this way you can write the three address code for the for loop. If the condition is true, you're going to execute the statement S and E3. If the condition is not true, you will automatically come to this statement, which is leading you to go to the last level. Fine. Let's take an example. The same examples, this one. Let's say this is the same example where the statement S is A equals to B plus C. Fine. So for I equals to 0, I less than or equal to 10, I plus plus, and in every execution of the for loop, A equals to B plus C is done. Now, at the very first, we need to do the initialization. So I equals to 0 is done first. After doing this, we need to check the condition I less than or equal to 10 or not. So if I is less than or equal to 10, we have to go somewhere. We'll be writing where we have to go later with the use of the backpatching. Let's say this level is L1. But if this condition is not true, we will certainly go to the last. So this is the unconditional jump. If this condition is true, let's say at L2 level, we have to do this A equals to B plus C. So for performing A equals to B plus C, we have to write 3 address code. So T1 equals to B plus C. And then in the second step, the value of T1 is assigned to A. Then we need to do this I equals to I plus plus, which is actually I equals to I plus 1. So let's say this is done in 2 steps with the 3 address code. T2 equals to I plus 1. And after this, the value of T2 is stored in the I. So I equals to I plus 1 cannot be written in the 3 address code. We cannot use the same variable on both the sides, left and the right. So that's why we have taken the use of, we have used the third variable T2 here. So after doing so, means after B A equals to B plus C and increment tick, you have to go to check the condition again. So you have to go to some level for checking the condition. So for the level for checking the condition is L1. So you have to go to L1. Fine. Let's say this is the last level. So in the backpatching, if I is less than or equal to 10, the condition is true. You have to come to L2 stage. And if this condition is not true, then you are automatically coming to this statement, go to last. So this way you can write the 3 address code for the for loops. Now let us think about switch case construct. And for this switch case construct, let's say it is of type switch I plus j. If this is the switch based on the value of I plus j, we're going to take some decision. Let's say if the case is 1, then we are going to do A equals to B plus C and then a break statement. And if case is 2, we are going to do A equals to B multiplied with C and then a break statement. But if I plus j is neither 1 nor 2, then in the default case, this is default, in the default case you're going to say A equals to B division C and then break. Fine. So this is the switch case construct and we have to write the 3 address code for this. So what is happening here, that we have to first find out the value of I plus j, and depending on the value of I plus j, we have to either perform this case 1 or perform case 2 or perform the default case. Fine. So at the very first, we will be writing the value of I plus j. So the 3 address code for this, let's say t equals to I plus j. And having found the value of I plus j, you will go to test the value of I plus j, depending on which you will call case 1, case 2 or the default. So at which of the level this test is done, we do not know as of now. We'll be doing it later. Now we're going to write the case 1. So let's say level 1 is defining the case 1. So A equals to B plus C can be written in 3 address code as, let's say T1 equals to B plus C and then A equals to T1. Having executed this A equals to B plus C, we will go to the end. Fine. Let's say the last level or the end level is last. Similarly for case 2, we're going to write B A equals to B multiplied with C. So in 3 address code it can be written as T2 equals to B multiplied with C in the first step. In the next step, A equals to T2. Having executed all these statement A equals to B multiplied with C, we will have to go to the last using the break statement. So go to last. Fine. And if this is neither this is true nor if neither case is 1 nor case is 2, we have to do this A equals to B divided by C and then break. So again, this can be written in the 3 address code. A equals to B divided by C in 3 step. So T3 equals to B divided by C, and after this A equals to T3. Having executed these two statements, we will have to go to the last. So let's say go to last. This is the unconditional jump. Now we have to actually test the value of I plus j, depending on which we will have to execute either L1 or L2 or L3. Okay, so here we are saying that there is a label test, and it will be testing the value of I plus j. Okay, so let's say after computing the value of I plus j in t, we are going to test, and test checks the value of t. If the value of t is 1, then it makes a conditional jump to level 1. Case 1, level 1. If the value of I plus j is 1, we are going to this level. If this is not true, then it will check if the value of t is 2, then it will go to L2 level. Okay, if the value of I plus j is 2, it will come to this level, case 2, and will execute this statement. So this is done in the L2 step. Fine. Now after this, if neither this is true nor that is true, means case is neither 1 nor 2, it will go to the default one. So it is an unconditional jump to L3. Okay, and after this, the last level. We are defining this last level because after executing case 1 or case 2 or the default, it has to come out of the switch case construct. So this way the switch case construct can be written. Thank you.